Hi, I am Raj Vijay Singh. I welcome you all to Mathscriber. I am in the process of creating a complete theory course of combined mathematics step by step with no step skipped. This is lesson number 2 of trigonometry tutorial series. In the previous lesson, I discussed about basic trigonometry values and created a basic trigonometry value table. In this lesson, I am going to discuss how to find many trigonometry values with the help of basic trigonometry values table and the Quadrants Rule. This is part 1. I am going to discuss the theory, and in part 2 I will be doing 2 example questions. Before I start, I must say, if you are fond of advanced math stuff, please click like and subscribe to stay tuned. To get to know about my advanced level classes, visit mathscriber.com or dial this number. So here we go, let's get started. In lesson number 1, I discussed about basic trigonometry values. To find many trigonometry values, we follow a theory called Quadrants Rule. As I mentioned in the previous video, we can include any angle inside a circle. Now let's say there are 4 quadrants. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth. So, if this is 0 degrees and if we consider anti-clockwise as the positive direction, now this is 90 degrees. So, every angle between 0 and 90 degrees comes in the first quadrant. For an example, 40 degrees, let's say 80 degrees, so it belongs to first quadrant. Now, if this is 180 degrees, angles like 120 degrees, 150 degrees comes inside this second quadrant. So this is 270 degrees. Angles like 220 degrees, 250 degrees comes in third quadrant. And after the rotation, this will be 360 degrees. And angles like 300 degrees or 330 degrees comes in the fourth quadrant. Now for an example, if you consider the negative values, now let's say negative 30 degrees straight away comes to fourth quadrant because it goes clockwise and the positive angles goes anti-clockwise. And to do the conversions, we use these trigonometric conversions. First is 90 minus theta, other is 90 plus theta, other is 180 minus theta, 180 plus theta, 270 minus theta, 270 plus theta, 360 minus theta, 360 plus theta. Now, if you are dealing with odd multiples of 90 degrees, odd multiples of 90 degrees, remember sine change to cos, cos change to sine, tan change to cot. Now just don't worry if you are not understanding what I'm writing here temporarily, because soon I go for the example, you'll understand what I'm meaning here, what I mean by these conversions. Okay, now if you are dealing with even multiples of 90, now odd multiples means 1 into 90, 90, 3 into 90, 270, 5 into 90, which is not here, 440, 450, my bad. So it's like odd multiples. Even multiples means 0 into 90, 0. 2 into 90, 180 degrees. 4 into 90, 360 degrees. And 6 into 90, 540 degrees. Means if you are multiplying by odd numbers, this 90 degrees, we call odd multiples of 90 degrees. If you are multiplying by even numbers, we call even multiples of 90 degrees. So when you are dealing with even multiples like 180 degrees, 360 degrees, no change will happen. Sine will be sine, cos will be cos, tan will be tan. what I am mentioning here is, now let's say the angles between let's say we consider angle theta between 0 and 90 degrees. That means we consider about the first quadrant. Okay, now in the Quadrants rule we call all S, T, C. That means any trigonometry values inside the first quadrant will be positive. Everything will be positive. Any sine value will be positive, cos value will be positive, tan value will be positive. For an example, 90 minus theta means you go till 90 minus, you are coming back, so it will be the first quadrant. So any value we write as sine 90 minus theta, cos 90 minus theta, tan 90 minus theta will be positive. Now here only sine is the boss, sine will be positive, but other two will be negative. So if you consider 90 plus theta, which is you come to 90 plus, you are going forward, so it is inside the second quadrant. So if you consider sine value of 90 plus theta or 180 minus theta, which comes to 180 and going back, so still in the second quadrant. So just if you consider the sine, cos, tan values of 90 plus theta and 180 minus theta, sine values will be positive, but cos, tan values of this 90 plus theta and 180 minus theta will be negative. Okay, so and now tan, here tan is the positive one, so sine will be negative, cos will be negative, and tan will be positive. So if you consider sine, cos, tan values of 180 plus theta or 270 minus theta, sine and cos will be negative, but tan value will be positive. And the fourth quadrant only cos is positive, so sine will be negative, cos is positive, tan is negative. So if you consider 270 plus theta or 360 minus theta or just minus theta, which goes straight away down, only cos value will be positive and other two trigonometry values will be negative. So now if you consider the first quadrant, okay, so that means 90 minus theta, so sine 90 minus theta, sine 90 minus theta, and 90 minus theta means first quadrant, which is sine, cos, tan, all the triples are positive. So sine 90 minus theta will be plus cos theta, cos 90 minus theta, odd multiples of 90, cos will change to sine, and it is the first quadrant, 90 minus theta, so it's positive, cos is positive, so this is plus sine theta. Now tan 90 minus theta, odd multiples of 90, 90 into 1, so tan will change to cot. First quadrant, so tan will be positive. We consider this side, not here. These are just answers. Now tan is positive in the first quadrant, so this is positive. Lots of students mess up because they think this we consider. No, we consider this one here, cos positive, tan positive. So if you consider an example, now let's say sine 30 degrees, we can write sine 30 degrees, sine 90 minus 60 degrees, which is same 30, and when you are dealing with 90, sine change to cos, and instead of theta here 60 degrees is there, so we write cos 60 and 90 minus theta plus cos theta, because first quadrant this is plus cos 60. Now sine 30 is half, so cos 60 also, if you remember the basic trigonometry values table, this is half, so it works, this conversion works. So now let's see, I'm erasing this. Let's consider about the second quadrant, which is between 90 degrees and 180 degrees. Now sin 90 plus theta dealing with 90, odd multiple, sign change to cos, and 90 plus theta entry into sine area, which is sine is positive. So sine is positive, we don't consider cos, we consider sine. This is just an answer, this is what we bother about. So this is plus cos theta, cos 90 plus theta equals dealing with an odd multiple, so cos change to sine, sin theta, and 90 plus theta enter into second quadrant, cos is negative, so cos answer should be a negative answer, so this is minus, and tan 90 plus theta equals odd multiple, tan change to cot, and this is second quadrant, only sine is positive, so tan has to be negative. Now example, now if you have an angle, now let's say cos 150 degrees, we can write it cos 90 plus 60 degrees equals dealing with 90, so cos change to sine, and it is minus sin theta. Instead of theta we have 60 here, so minus sin 60, and if you remember the basic trigonometry values table we discussed in lesson number 1, you remember sin 60 means root 3 over 2 minus root 3 over 2. Now if you consider this one 180 minus theta, sin 180 minus theta equals, now dealing with even multiples of 90, 2 into 90 is 180, so sin change to sine, so no change, so sin 180 minus theta means sin theta, cos 180 minus theta, and this is positive because 180 minus theta means entry into second quadrant, sine is positive, so now cos 180 minus theta, it is now second quadrant but even multiple, so cos will be remain as cos, but it is minus because this is second quadrant, cos can't be positive. Now tan 180 minus theta equals just same as minus tan theta. Now example, same example, now let's say cos 150 degrees, we can write cos 180 minus 30, which is 180 minus 30, same 150, so we can write it, now dealing with cos 180, so cos 180 minus theta means minus cos theta, minus cos, instead of theta we have 30 degrees, so cos 30, if you remember, it is root 3 over 2 with minus root 3 over 2, we get the same answer. Okay, so now I'll be moving to the third quadrant. Now theta between 180 degrees and 270 degrees, so now sine, now I'm talking about this one 180 plus theta, 180 plus theta, you are going down and coming to third quadrant, 270 minus theta, you come long way 270 minus, you are reversing your vehicle, so it's going back, and same third quadrant, so I'm talking about these two, so sine 180 plus theta is equal to, now 180 is an even multiple, 2 into 90 is 180, so it is even multiple, sine will be sine, so it is sin theta, but now only tan is positive, sine is negative, so it is minus sin theta. Now cos 180 plus theta equals, now cos has to be negative and 180, no change of cos, cos means cos, so it is minus cos theta tan 180 plus theta, which means tan is entering into its quadrant, its area. So tan will be positive and tan will be tan, since this is 100, 2 into 90, even multiple. So it is plus tan theta. Example, now let's say we consider tan 225 degrees. Now tan 225 we can write 180 plus 45, which is tan 180 plus theta is tan theta. So 180 plus theta means 45. So it is plus tan 45. If you remember the basic trigonometry values table, tan 45 is 1. So this is positive 1. Now if you consider 270 minus theta, sine 270 minus theta, which is 270 odd multiples 3 into 90, sine will change to cos. So this is cos theta. By the way, 270 minus theta entering not to the sine's area, which is third quadrant, sine's area is second quadrant, so sine should be negative. As always remember, we consider this side, not here. So sine, we are not considering cos. Sine is negative in the third quadrant, so this is minus theta. Now cos 270 minus theta equals, dealing with an odd multiple, so cos will change to sine, and it is not cos area, it is third quadrant, so this is minus sine theta, and tan 270 minus theta equals, tan will change to cot, and this is tan area itself, so this is plus cot theta. Moving into the same example, tan 225. Now let's say we have tan 225. Now we can write it 270 minus tan 270 minus. Now when you subtract 45 degrees from 270, it will be 225 degrees. So now tan 270 minus theta, it is plus cot theta. Tan 270 minus 45, it is plus cot 45. By the way, cot 45, cot means reciprocal of tan, so this we can write it 1 over tan 45. Tan 45 is 1, 1 over 1 is 1. Boom, you get the same answer. Now we move to these two, which are the fourth quadrant. 270 plus theta means you come here, plus theta, enter into fourth quadrant. 360 minus theta, you come around, and minus theta going down, it's the same fourth quadrant. So where cos will be the boss, positive, other two will be negative. So let's look into that. I'm erasing this. Now theta between 270 and 360. Now let's say sine 270 plus theta, dealing with an odd multiple, 3 into 9 270, so sine will change to cos, and we consider sine. Only cos is positive, but most of the students mess up, they think cos is positive. This is just an answer, we consider this side only. So now sine is negative, so this will be minus cos theta. Cos 270 plus theta equals, cos will change to sine because 270. By the way, this is cos area, cos is the boss, so this is positive area, fourth quadrant, so this is positive, and tan 270 plus theta, which is 270, so tan will change to cot theta, and this is not tan area, so this will be negative. An example, let's say sine 300 degrees. Now sine 300 degrees, we can write sine 270 degrees plus 30 degrees, which is 270 plus theta, which is minus cos theta minus cos 30 degrees, so equal to minus root 3 over 2. Now moving to the other one, 360 minus theta, it is now sine 360 minus theta equals, now 360 means 4 into 90, which is an even multiple, so sine will be sine, cos will be cos, tan will be tan. Okay, now sine 360 minus theta, we can write same sine theta, but you come around and going down, enter into fourth quadrant, sine can't be positive, so this is negative, and cos 360 minus theta and 360 minus theta, you are entering into same cos region, so cos will be positive and same cos, and tan 360 minus theta will be minus tan theta. Example, we'll take the same example, sine 300 equals sine 360 degrees minus 60 degrees. Now equals, now sine 360 minus theta means minus sine theta, so it is minus sine 60, which is, now sine 60 is root 3 over 2 minus root 3 over 2, we get the same answer. Now are you supposed to get the same answer in two methods? No, you are allowed to select whatever your convenient way, but I am just giving this example to convince you that we can use these conversions to find the values of 300 degrees in two methods. Now moving on to 360 plus theta, and before I go for the 360 plus theta, I think I must explain this, and which is very important, and even some teachers ignore this. Now let's say sine minus theta, cos minus theta, tan minus theta. Now minus theta, now if you know, anti-clockwise we consider as positive. Now means positive direction, just anti-clockwise. Now let's say 150 degrees we go anti-clockwise and we find out it's second quadrant. But minus angles, now let's say minus 40 degrees, straight away it goes down, it's the fourth quadrant. Minus 120 degrees, it will go and straight away it enters the third quadrant. So now minus theta, straight away it sinks to the fourth quadrant. So sine minus, and which of this? Now no 90, that means 0 into 90. 0 we consider as an even number, so sine will be sine, cos will be cos, tan will be tan. So sine minus theta, sine theta, but this is cos area, so this is minus sine theta, cos minus theta, cos theta, but this is cos region, this is positive, and tan minus theta minus tan theta. And example, no, let's say sine minus 45 degrees, sine minus theta minus sine theta. So this is minus sine 45 degrees, and sine 45 degrees 1 over root 2 in front of this minus, so minus 1 over root 2. Now move into the last part, 360 plus theta. sine 360 plus theta. You come around a journey, and now again we start with the first quadrant. Now we can keep following, but these basic conversions will give you an idea to how to make any conversion, so just this is enough. So now 360 plus theta is coming to first quadrant. Everybody will be positive, and this will be exactly same like the normal trigonometry values. 360 plus theta will be sine theta, cos 360 plus theta will be cos theta, all are positive, and tan 360 plus theta will be plus tan theta. Now let's say an example. Let's say tan 405 degrees, which is 405 degrees, which is tan 360 plus 45 degrees, which is same tan theta, which is tan 45 degrees. So answer will be 1. Now this is all for the theories of quadrants and the trigonometric conversions to find mean trigonometry values, and in part 2 I'll be discussing 2 example questions, so you may have a proper understanding how to use it in practical problems. So let's meet in the part 2. Goodbye.